Last week we talked about t-test, and this is the original form I asked you to write. But this is very rough. This is a draft. When presenting your writing to report the result of your t-test, you need to tailor to the context of your research. So I changed the format style a little bit to make it more clear for us to the readers to read. So let's see the comparison between these two. So basically, the context of these two are about the same. So trying to identify whether male and female differ in their support level of NJ2. So this is one of the Chinese. But remember, in our writing, let me turn off the fan. Because our GP is based on it, you have to write your GP in English. So it's not right to put here, this one over here. So you cannot use Chinese in your body text. So you have to change. And also in the meantime, you want to make it more clear for the readers to read. So we have to change this. So look here. The female and male and female equally support NJ2. So you have to give it explanation. NJ2, the declaration of the unlawful events under Taiwan's authoritarian era. So this is NJ2. Okay, so the following is almost about the same, but with some minor revision. So an independent samples t-test indicate that there was no significant effect for gender. So this is the same, right? There was no for gender. Okay, so we have WIP, and remember, why do we need to put this? Why do we need to identify the t-score and identify the p-value? Because the p-value here is to support your argument. You say there was no significant effect for gender. So p-value is here. So this one is to support your argument here. This is the same, right? Okay, so despite the following statement is a little bit to change. A little bit changed. So despite the male, the here and standard deviation showed higher support level than female. So the 3.73 and standard deviation is wrong. And standard deviation is equal to this. But we have to let our readers know one fact, that what is the meaning of 4 and 3.7. So I add in a little bit illustration for this one, so you can see. So despite both male, so the mean is 4 point, and the female were supportive to, there's a typo here, supportive to NJ2, but their support level were not significant different. So this one you can see, both of these 4 and 3.7 is higher than 3. So they should be supportive to this. But their support level were not significantly different because of this. Okay, so this would be a better way to illustrate. Okay, so when you write out your report, you should follow this style, but not this. Okay, because you cannot put Chinese over here. You can't. Okay, let's see the next writing sample. So we have another writing sample here. It denotes significance. So this is the original form. So you can see we have Chinese here, right? Okay, but so we can change this a bit and make it more readable. So many pundits observed that men were more supportive to transitional justice than women. And this passage is a little bit different, is the same. More pundits observed men were more active in supporting transitional justice than women. I changed this a bit. So many pundits observed that men were more supportive to transistor than women. So the following is about the same. So an independent sample t-test compared the means of males and the females level of support to NJ1. So this is the meaning of NJ1. This is in Chinese. So we have to change it. We have to change it to English. So an independent sample t-test compared the means of males and female level of support for NJ1. So this is the meaning. Okay, so let me move down a bit. So basically, NJ1, what is NJ1? So this is the meaning of the NJ1. So to compensate the victims and their immediate family under Taiwan's authoritarian era, confirm this general observation. So basically, you can see this is the same, right? And now starting from here, and we have a slightly different allocation for, so we can see from this section, this one to here is a little bit different from this one to here, although the context is the same. So you can see the difference between the mean of the 6 male support level. This is the mean, refers to this one, and that of that 20 females. Okay, this was significant. So you point out the p-value. And the only difference here is the meaning of your finding. So this indicates that while males and females were both supportive to such compensation, and such compensation is this one, right? You can see to compensate the victim, right? Male were significantly more supportive than female. Okay, so over here, over here we did not describe the meaning of the finding, and this is the meaning of the finding. So with some differences between these two. Okay, so there are two differences. One, we don't use Chinese in writing. Second one, the previous passage does not highlight the meaning of the findings, but now we have the meaning of the findings here. Okay, this is another way to write. Okay, and let's move. So far, do you have any question? Any question? Okay, if not, let's continue to the next one. The next one is here. So paired samples t-test, we are using these two. There are two variables, R1 and R2, right? R1 and R2. So let's change this. So what were people's support levels for R1? And we have an explanation for this one. And R2. This is the meaning of the variable. So a paired samples t-test demonstrates that the support level for R1, the mean score is 2.5, standard deviation is this, and that for R2, the mean is this and that, inclined to be not supportive. Did you see? This is 2.5, less than, smaller than 3, and 2.54 smaller than 3. So you can see from 1 to 5. 3 is the median, the middle value, and 2 is not supportive, and 1 is very extremely very 这个非常不同意. So you can see this 2.5 is toward to the negative side. So we can see inclined to be not supportive, but had no significant difference. And you can see this is the evidence. Okay, so this will be more complete. So again, we try to avoid using Chinese. We have to change that. And also here we have the meaning, inclined to be not supportive, and had no significant difference. Okay, so this is another way to write it. And the last one is this. So that will be easier for us to read. So now we have two, there's a significant difference here. Again, we have a 2, 1, and 2, right? But now we have to make it more readable. So I try to incorporate small writing here. So how can we do this? Let me make it shorter so that will be easier to read. Okay, so this one will be easier to read, right? So you can see we have two variables. One is this, and the other one is this. So I have to change. The people equally supposed to demolish Chiang Kai-shek Memorial Hall. This is R1. And to retain negative cultural heritage. This is R2, R3. Okay, so a paired sample t-test showed that their support level for R3. This, since we have, then you don't have to repeat. Okay, oops, I'm sorry, this R3 and R4. No, this is R3, and this is R4. I'm sorry. Okay, so a paired sample t-test involved showed that their support level for R3. You don't have to repeat the the definition for R3 or definition for R4. You just use this directly. And that for R4, this one was significantly different. Okay, but you see this one, 2.29 is not supportive, and 3.64 is supportive. So as the Memorial Hall is regarded as one of negative cultural heritages. So basically, your respondents support this, but not support not support this. Okay, so you can see this one they support, but this one they do not support. Okay, why? Because the significant level is different. So basically, when you write out when you try to report the result of your analysis, you do not only identify the findings. It would be better for you to tell your readers the meanings of your findings in the same passage when you write out your quantitative analysis. Okay, so this is about t-test. So any questions so far? Folks, do you have any questions? Okay, I hope that you are still there. Don't fall asleep. So I gave you this how to this file. You can check it out. So how to report one-way results. So this guide 9 is from Statology. It's a very useful website if you want to have a simple analysis. So basically, what is the purpose for one-way analysis? You could call it one-way ANOVA or one-way analysis. So what is analysis of variance? Analysis of variance is called as ANOVA. It is a way. Well, one-way ANOVA is used to determine whether or not there is a significant difference between the means of 3 or more independent groups. So when we use t-test, it is used to compare the means of 2 different groups, 2, right? But how about more than 2? T-test is, if you insist upon using t-test, the process will be very tedious. So here comes the so-called one-way analysis. One-way analysis will be, its purpose is to compare the means. So more than 3 or more independent groups. So here, how can we do this? So for example, let's use use Yuting's files as examples. So let's take a look at about her files. So this is her data sheet, and we have data view here. So basically, When we start statistical analysis, you need to go first to produce a descriptive table. You have to some sort of descriptive statistic for you to understand the distribution of your data. So basically, if I were you, I would go to analyze and use this one, descriptive statistics, and use frequency. Frequencies is helpful for us to identify the distribution of your data. So I control A and drag them into this box. These are the all variables. So I click OK to see the distribution of the variables I have. So here is the output. So look here. We have 27 cases all along, right? You can see, and we can see this, and I will roll down. These are all about the attitude. You see this one? You can see the different frequency, and to see whether the distribution of your data is normal. And let's roll down a little bit quicker to see this one, the last one, because okay. So look at the location. The location here we have 1, 2, 3, 5, right? So and the number for Whitedao is only 1. So there is only one case. And let's see the education level. So education level is high school, college, and 博士. There's only one. So basically, this is not good for you to compare the means. And how about this one? Gender, we have a male and female, and we have an age group. We have only 2 subgroup, one subgroup and 18, another subgroup, right? So basically, if I want to use one-way analysis, this will be the only candidate I can use. Why is that? Because we have 3 groups, 1, 2, 3, right? And with sufficient number of cases. So when we conduct one-way analysis, we have to take away this case because this is only one case. Normally, when we use one-way analysis to compare the means, the number of the cases in each of the subgroup, we need to have at least 5. So this is qualified, and this is qualified, right? But this one is not. So basically, we need to take away of this, or otherwise it will be very difficult. There's no way for us to produce any kind of meaningful comparison. So let me run the first round to tell you, because of the Whitedao, there's only 1 student in this category, right? So let's see. We use analyze, and we use compare means, and all the way down to one-way ANOVA. This is one-way ANOVA. So we click it. So now let's try to include all the attitude variables here and put location here. Location is the independent variable, and all else are dependent variables. So let's see if we can have any significant result or not. Let's see. Okay. It's too huge. Let me take away this. It'll be easier for us. That is too much. Okay, let me do this again because one way location. Yeah, this is location, no doubt. So strange. It's not right. Okay, let me change this to, I see, I see. Okay, so analyze, and again we compare means, and now I use the post hoc. Post hoc is to compare whether the means are different, so it has to be used Tucky. Tucky is the most used one. We just use it. So let's see if we can produce any output. Do you see this one? The output here tells us. Now let me tell you what it means. Because at least one of the subgroups observation is less than 2, so it's not possible to conduct the so-called post hoc evaluation. Okay, so that's why we need to have a more than 2. Preferably, we should have a 5. That is the norm for our statistical analysis. So basically, as we see from here, this one, as you can see, frequency. You can see from here the location. The location, the white dot. So there's only one case here, right? Because there's only one case here, so we need to take away this group. Then how can you manage the data and take away this? Basically, we can go to data. And data, we can select cases. We don't want to have this one, so we can select cases. And we can use the screen if condition is satisfied, if. So if location, so we only choose location less than 3. That's 1, 2, and 3, right? See this one? 1, 2, and 3. So in this case, white dot will not be selected into the calculation. So we continue. Okay, and then click OK. Okay, and then you can see this one. Use all. This is the syntax. So less than 3, right? Okay, so let's see what happened to here. You can, again, we use analyze, and here, and frequency. And now we take away, we put over here, and now we use only location. Only location here, and let's see what happened. Do you see this one? We have excluded white dot and only keep this, and that. So now we can analyze it. Okay, so now I'm going to produce the 2 different kind of table, one-way analysis to compare the means. One is with significant difference, and the other one is not. Okay, so the first one, I'm going to use compare means one way. The first one is I will use, let's see, CC3, because I have checked it before, so that's why I know. So CC3, I put it here. Okay, let's see, and I use the post hoc. Post hoc is to compare whether the means is different. So you could just click Turkey. That's good enough. So I continue, and let's see the output. Okay, so here is the output. This one. This is the output. So for the convenience of the illustration, I will copy the output so that we can have a better view for this one. This one is the first. Okay, so let me open. So I copied this one and put up here. This is the writing examples for us. So here is the output. So based on this, I'm going to tell you how to write it out. Okay, let's go up. So this is the writing sample, and this is the output. Okay, so let's see what can we go to these two? The first one, we have to identify the scenario, just as here. You have to explain the situation. The first one, for example, here. So I write it, candidates in Taiwan often use the social media to promote their campaign videos. So look here. This is the variable name, right? Variable CC3. So I just write here, candidates in Taiwan often use the social media to promote their campaign videos. So this tells the readers what we focus on. This is topic. But were people from different areas in Taiwan, I want to move on to focus on different areas. Equally interested in watching these sorts of videos. Look here, interest, right? So a one-way ANOVA was performed to compare the effects of location. The location is the variable name, so I use this is capitalized location. And the CC3 is here. So the meaning of the CC3 is this, right? So I just write it out, put it in the parentheses. Felt more interested when watching campaign videos via social media than other means. Okay, so this is the meaning of CC3. So CC3. So this one-way ANOVA, so it refers to this one, right? So it revealed that there was a statistical significant difference in mean CC3 score. So this is the mean CC3 score between at least two location subgroups. So these are the subgroups, 北部, 中部, and 南部, right? These are the subgroups. And this number, because we say there is a significant difference, statistically significant difference, right? And this is the evidence. It's very important to identify the evidence. And where does we have these numbers? Basically, the F values, you have to check it. The ANOVA is here. ANOVA, and the F, the within group. This is the between group degree of freedom. This is within group degree of freedom. So you can see 2 and 21, 2 and 21, right? Do you see that? And based on these two numbers, these two degree of freedom, the F value is 4.248. So this is 4.248. And the significant level, the p-value is 0.028. Okay, so this, here we provide the p-value to support the illustration here. There was a statistically significant difference. So you have to be careful about this one. Okay, now, once we have identified this significant difference, then we have to go for a post hoc test. So this is a post hoc test. So post hoc is that after we have collected the data, we go to compare their means. And now we have identified there's a significant difference, right? So we continue to compare whether there's a significant difference. So that's why we use post hoc evaluation here. Okay, so now the Taki HSD test refers to this one. For multiple comparison, found that the mean CC score, CC3 score for respondents from the northern Taiwan, this is the northern Taiwan. Okay, let's give the number here. This is this one. Northern Taiwan, southern Taiwan, southern Taiwan, sorry. This is southern Taiwan, right? So southern Taiwan is 2.77. Is significantly lower than that of the respondent from northern Taiwan. So this is northern Taiwan, 3.83. So you can see the northern and southern, and the significant level is this. Do you see this one? So we have to identify the p-value. P-value is equal to this. the comparison between northern and southern. So this is one is 0.027. And now we have to consider the possibility of the two deviation. So we have a confidence level, confidence interval, 95% of confidence level. This is refers to this one. 95% of the confidence level is equal to 0.11 to 2.02. So we have to identify the number. Okay, so see this significant lower, right? Significant lower. And then we have to explain. We have to explain. They are significant difference between these two, 北部 and 南部. But how about the other two comparison? 南部 and 中部 and 中部 and 北部. There is no difference. So we can see there was no statistical significant difference in mean score between respondents from the northern Taiwan. Northern Taiwan is this score, right? And from central Taiwan. Central Taiwan is 3.4. So we have the number here. Okay, I have to be careful by using this one. So I can take this away. Okay, so that is a 3.83 versus 3.4. And the p-value. The p-value is here. You can see the p-value is here. So 北部 and 中部, the p-value is here, right? So you just identify the p-value. And that from the central part and southern part, Taiwan, have no significant difference, and respectively. Okay, so basically we have two ways to write it. Let me rewrite again. Okay, so this is one way to explain. There were no statistically significant difference between central and 北部 and 中部 and 中部 and 南部 because the p-value is here. Okay, so this is one way to describe with significant difference. So normally you do not remember. I put up here is just one example. It's not for you to just simply copy and paste here. Just for you to understand how to identify the number here. Okay, let me point out. Basically, these are the number you need to have. And these are the number you need to identify. So let's see this one. This is significant difference, right? And this is another set of comparison. This one and this one. And this one is from 2.77 南部与中部. So you can see the difference is here. And there's another one. So we have this and this. So the difference between these two is this one. So basically, you need to have the compare and this one. This one and this one, the difference is this one. Okay, so let me just copy this for you to. So that would be much easier for you to compare the different colors. Okay, so these are the numbers you need to have. I will save the file and then later I will post on our night group again. So any questions so far? 各位有没有问题啊？ 哎呦，好的，我再来讲一讲呗。那基本上弯位的话，它是用来比较三组跟三组以上的平均值的差异。我们讲说平均值差异，比如说我们刚才讲说这边你可以看到，这边是不是有南部学生的反应、中部学生的反应跟北部学生的反应嘛？然后他们反应的平均值呢是2.77、3.4跟3.83，对不对？那这三个数字平均值是不是有显著差异呢？这是我们有兴趣的嘛。那在做 one way ANOVA 的时候，对不对哈？你一定要先确定，就是说，我们一定要先去检查它是不是这个这个差异是具有显著的。那显著的差异，第一个我们一定要去 identify 这个 number，最重要的这个了，先去看这个，就是 output 一定要先看这个。如果它这个是有显著差异的，我们才需要看这个。如果它没有显著差，如果说假设这个是差多于0.05的话，那么后面这一块你就不需要看了，后面就不需要做，因为这个很明白告诉我们说，它们组间三个平均值是没有差异的。好，所以我们基本上是两个程序哦，一个是从这里开始1，然后才要做到2。当你1说有了 yes， 那我们才走到2，这是 yes 的时候有显著差异。像这个状况是有显著差异的，对不对？然后呢，这是有显著差异的。如果是 no 呢，那么我们就到此为止，就只要讲这一块就好了。这样清楚吗？好，那我们来看怎么样。我给你另外一个例子，另外一个例子是它没有显著差异的比如说像 analyze， 我把另外一个拉进来。我把这边我也用过 DBC， 我把它拉进来，这有两个。那一个是前面是有，后面是没有，因为我测试过了，所以我知道。所以我们把它看一下，对不对哈 ？OK， 那我现在先把整个把它删掉，太乱了。那我再重新跑一次哦，然后 analyze。所以你看哦，这两个对不对？我把它跑一下。那跑一下，你看哦，我们第一个要检查的就是说，我们先比较这 CD3 来用这个北部、中部、南部的时候来做三组的比较，它有没有显著差异？有，一定有，因为0.028有嘛，对哈。那因为有，所以我们才会去看下面的数据，才会去走到下面。那我们来看这里，那你最常用的网是不是 Dcar 呢？我们发现说这个三组对不对哈？三组。这个是0.328，换句话说，我们就不需要再走下去了，对不对？可以看得出来吗？那这两个的论述我们再把它，等一下我们再把它，我再把它一个一个走，可能会比较容易一点我先把它拿掉，先把第一个弄出来，然后再来第二个弄出来，OK。所以我们看一下第二个 one way ANOVA， we take away CC3 and put in DBC 这个DBC CEB 这个拉进来，一样哈。我们来看一下，我们刚才讲说，我们当跑出这个 ANOVA 的一个 table 的时候，记得我们这边有 post hoc。那基本上我们要先去检查，就是说，那这个显著度是不是有？很显然有，对不对啊？那我们才会去接着探讨下面的东西，这个有。然后呢，我们看下面这个，这个是 talking about did you use is Dcar is the most frequently used social media website you use, right？ 我们来看这边哦。那这边的话，这边显示度，我们显著度是不是这里了？那0.328嘛，那换句话说，底下的其实就不需要看了，因为它没有显著差异，就没有了，所以这一块就不需要了，这样了解吗？那我们现在我们来看一看我们怎么样来产生针对第一块来做解释。那我们在 我们先理解说这个是有差异，这个差异怎么来的？那我们要考虑它的 f value。那 f 值呢是必须要有两个，这个 f value。F 值它是建构在两个 degree of freedom， 一个是主间，一个主内。主间叫做within group， 不是，这 in between group， 然后组内叫做 within group， 有21个，一共有3组嘛。然后呢，这是2跟21，在这2跟21的状况之下，它 F value 是 4.248， 那么它的这样的显示度有多少呢？只有 0.28， 所以小于 0.05。那这种状况下，那我们就会进一步去思考说，那到底是谁跟谁不一样？表示说这一定有其中不一样的嘛。那我们来看一下，北部比较中部呢，它显著都是这个。那么北部比较南部呢？北部比较南部呢，我们发现这显著是这个。换句话说，这个差异告诉我们说，北部的学生的平均值跟南部学生的平均值，在这一项来讲的话，它是有显著差异的。然后在95%的信心水准之下，就95% of confidence interval 是来自于0.11到2.22，这要把它标注出来。那各位还记得什么叫做信心水准吗？什么叫95% of confidence interval？ 还记得吗？有谁能够知道？这跟我们的所谓的 normal distribution 有关系。我们在上课是不是有谈到正常分配吗？还记得吗？对不对？然后我们也讲说这是平均值，当我们的 SD 等于0的时候，这是平均值。那 how about -1、-2， 然后 +1， 2个标准差。所以换句话说，在2个标准差里面，对不对哈？2个标准差里面，这有95%的资料会在这里面。所以换句话说，我们所讲的这个0.11是在这个地方，2.02是在这个地方，这个就所谓的95% of confidence interval， 指的就这个意思。意思就是说，他们两个差异的值，就是这两个的差异的值这两个差异的值，会在95%的区间之下，他们差是0.11到2.02之间。那他们你看他们现在差了多少？2.77跟3.83嘛，他们差多少？他们是不是差1.064？对不对？但是这1.064对不对？是在这个区间中的一个数字啊。那它的95%的信心区间里面，可能是0.11到2.02。但不管怎样，它这个差的显著程度是 p 等于0.027，所以它是有差异的。那我们下面就是解释说，这个谁有差了，南部跟北部有差异。那么南部跟中部有差异吗？你看他们是不是在同一组？表示他们没有差异。那么中部跟北部呢？他们也没有差异。那我们从看前面的，其实可以看得出来了，北部跟中部有没有差异呢？他们的差别是0.433，可是它却不显著。那么中部跟南部呢？他们的差异是0.631，可是也不显著。这样可以看出来吗？好，那我们写出来的时候就变成这样写了，就变成这样的写法，只是说写的比较长一点而已啊。但真正你写的是基于这样的一个表格 output 出来的。OK， 还有没有问题 ？Hello， 其他同学知道了吗？So this passage is just for your writing, and maybe you can just follow the style. So look here, identify. This is the topic sentence for the passage, right? So donut absorbs fat in various amounts when they are cooked. So now an experiment by this, and I give it a footnote. So this experiment is done by Wu Baochun. So I continue to describe. Peanut oil and corn oil are unsaturated fat, and lard is a saturated fat. So in this experiment, 10 donuts were cooked for 10 minutes with 3 different fats, 6 times with corn oil, 6 times with peanut oil, and 6 times with lard. 所以换句话说，这边哦，它3种不同的油，然后呢，把那个你的那个 donut 把它放进去，给它炸那个各炸10分钟，然后来试试看，有6次6次6次。So after being cooked, the average absorbance of corn oil, peanut oil, and lard was 这样子 and this, right? So already the average absorbance is like this. So one way ANOVA indicates that. So here is the name of the test. One way ANOVA indicates that the donut's absorbance of these 3 factors was significantly different. 那你要讲 significant difference， 对不对？那你必须要提出证据嘛。那你看看这边来讲，就证据啊 ，this is the evidence. F 在2跟15的状况下是 4.156， 它 p value 哦，这个 p value 我写错了。OK， 0233哦，答案是这个0233，那很显然是 significant，right? And they could be classified into 2 significant different subgroups. 那请看 Table 1。那你看这个跟这个是不是一样？各位看到吗？是一样的，对不对 ？OK， 好，那这什么意思呢？这个意思就是说，当我们把它设的 alpha 的 value 等于 0.05 的时候 ，OK， 那这2个相等的几率，对不对哈？啊，他们2个怎么样呢？他们2个不同的几率是他们2个相等的几率是 0.14%， 然后这个放在一组的时候，可能的几率是100%，但是这2个是完全不同组的。不同组换句话说，这2个会相等，这单一的会相等，在这2组呢是完全不一样的2个个别组的意思。当用 0.05 来做切开的时候，所以这个可以看出来它们是一组的。这个是另外一组，那我们可以看出来 ，so we can see from here, see table 1. They could be classified into 2 significantly different subgroups, one group 1 and group 2. One was corn oil and peanut oil, 这是第一组 ，and the other one was lard, 第二组。那我们可以看出来 ，this finding supports the research hypothesis that donuts significantly absorb more saturated fats， 这是个 saturated fat， 对不对 ？than unsaturated fats when they are cooked。那我们答案就出来了，这是另外一种表达的方式。OK， 那我们来看看这种 style。这种 style 在哪里呢？它其实是一种融合的写法，它把你整个实验对不对哈交代出来你的主要的一个这个 topic sentence 你的重点讲出来，然后实验说出来 ，done by whom also identify， 然后呢结果过程怎么样，然后结果是怎么样 ，OK， 结果是怎么样，然后把 meaning 把它讲出来，所以它其实也是一个简单的一个 passage 的写法。然后呢这边有一个很重要的，你看。我们把它，请看 Table 1， 那你把 Table 1弄出来。所以你想这个 Table 1跟这 Table 1其实是一样的，只是稍微把它改一下。有时候你是可以把它拿上来，但是必须要 to the point。OK， 所以这也是一种方式。这样了解吗 ？Hello， 各位有问题？了解哈，来，那。这样的话，对不对哈？那么你们的 homework for statistical number 6就很简单了，那就是呢，从你们的自己的资料库里面找出来，然后做出一个像类似这样的一个 writing 出来。那我会把这个给你当然待会你们就那个依照这样的方式来写一下，这样就好了。想了解吗？有没有问题？没有的话，对不对哈？那一样哦，这个作业是在礼拜6的中午以前要交给我。OK。
其实今天的 lecture 要录影。
我有录影啊，有啊 ，Yeah，I record。